So notes number 2 was talking about our rules for when we have like bases. So when we're multiplying variables with like bases, we need to, of course, add the exponents. Okay? So we're going to add exponents when we have the same letter, and as long as the base is the same, it's totally fine because we're just kind of grouping things together. So if we have x to the 5th times x to the 4th, we're going to add these little numbers and get x to the 9th, which means we have 9 x's. Now, if there is no exponent written, then the exponent is a 1. Okay, so if it's just plain old x and it's sitting there looking all nice and cute, well, that is actually x to the 1st. So you can write a 1 if you want. So in this next one, we have a times a to the 3rd. Let's remember that there is a 1 there. So if I add the 1 with the 3, that really means we have 4 a's. Okay? And in the last one, if we have n squared times n squared, well, then we have 4 n's, and n to the 4th. All right, but again, that's kind of a review of what we talked about with exponents before we did exponential functions. Now, on the next page, we're going to talk about, same page for you, next page for me, multiplying monomials. So here we multiply the coefficients and add the exponents. So we're going to have not just a variable, but we're also going to have a number out in front. All right. Now don't let that be distracting, because we can rearrange this. We could use our commutative property. If we have 2x to the 3rd times 5x squared, we're going to multiply the 2 and the 5 as normal, 10. We're going to add the exponents of the like bases. So if I have 3x's and 2x's, I have 5. And you know what? Not everyone's going to have to do that, but if you like kind of seeing how we're arranging this to make it easier for you, by all means, go ahead and do that. With the next one, 4x times 3x, remember, drop in the 1s just to make sure we remember they're there. 4 times 3 with 1x and another x. So that's going to be same old 12, still multiplying coefficients, that number in front, but then adding the exponent. So the 1 plus 1 making 2. Just kind of building it up today, right? It's Monday. I'm sure some of us are off to a slow start. Finally, 6x times x to the 2nd. I'm not even going to rewrite it. It's kind of like how we need it. With the number first, just 6, and then 1x and 2x's make 3. Okay? So all of these properties are going to be involved for what we're about to do next. And so this is a property that you probably have used before, the distributive property, right? So multiplying a monomial times a binomial. Now don't be intimidated by these words. Mono just simply means 1. Binomial means 2. So we've got some prefixes in the real world to help us remember this. We got monopoly. How many people win the game Monopoly? If it's a monopoly like Amazon, what are we worried about? We're worried about Amazon being the only one left. No other place to buy anything because they're a monopoly. They're going to take over, right? So uno, or just 1. And a binomial, kind of like your bicycle. How many wheels on a normal bicycle? 2, right? We got 2 wheels on there. So you can kind of see the prefix tells a lot about what the polynomial is. So looking at the chat, just kind of seeing here. And all right. Just kind of looking at how Google Meet works here. But anyways, multiplying a monomial times a binomial means we need to distribute the monomial to both terms. And I mean 2 terms because it's a binomial. All right? I'm not going to do a lot of rewriting with this. I'm hoping you can see it with your eyes here. I am going to try to encourage you to do a little bit of a method here where you just kind of show where it's going, right? So we're showing the 2x times the 3x. So we're going to do all of this right now as 6x squared. Was that too fast? Hopefully that wasn't too much too soon. Can't see the reaction like I normally would in a classroom. How about 2x times negative 1? So we'll go ahead and distribute that as well, and you have to bring along both the number and the variable, so 2x. All right, so first one down. Hopefully we're doing all right and hang it in there. Next up is x squared. So we have to distribute this as well to both terms because that is a binomial. If it was a trinomial, meaning 3, we'd have to distribute 3 times. Don't forget about maybe the 1 that's above the x. So this becomes 4x to the 2 plus 1, 3. And then again, x squared to 3, making it 3x squared. All right. Just some work with distributive property. We've seen this before. We've been down this road, right? Lastly, 4x squared getting distributed to the binomial. Multiply the coefficients, the number in front of the variable, as normal. 4 times 2 is 8. X squared and x squared makes x to the 4th power. And go ahead and do that again. Pass it along. Negative 20 x squared times x, x to the 3rd power. Okay? So there you have it. So we're going to multiply these binomials by distributing both parts of the binomial to the second. I'm going to break up the first one into 2x and 3, and then distribute the 2x to the 3x minus 4, and then the 3 to the 3x minus 4. And so once you do that, we distribute here and here. That's going to make 6x to the 2nd power because of the 1 and the 1. Very simple, but don't forget. 4 negative times 2 is negative 8x. So we've distributed the both terms there. Now let's do the same thing here. It's going to be 3 times 3, 9x, 3 times negative 4, negative 12. Okay? Once we go that far, we would want to try to maybe add any like terms. So here in the middle, we add like terms. Now be careful. There is a 1 and a 1 there, but based on the Nearpod from the last lesson, I only change the number in front, the coefficient, negative 8, positive 9, that's just 1, and then the x stays. All right, we do not add those exponents. It stays x to the 1st power, then minus 12. So it leaves it off in a 3-piece polynomial called a trinomial. And trinomial, kind of like your triceratops, your tricycle, where it has 3 wheels. All right. Any questions? Again, keep them coming in the chat. And now time for the box method. All right. There is FOIL. I'm not going to use FOIL. It's another way that teachers talk about this, but I would prefer that if you're going to do a different way, try the box method. So what the box method does is it kind of helps you organize your work. You break up in the binomial into the 2 parts. The 2x gets this column, the 3 gets that column, and then break up the second one so that the 3x gets this row and the negative 4 gets this row. So you'll always use the sign in front. All right, make sure that stays with it. Now when you go and multiply, it should make it a little bit easier. So it's kind of like playing the old game Foursquare they used to do outside the elementary school, right? 2 times 3 is 6, x times x, x squared. Because we are multiplying, we would add the exponents. 3 times 3x, this box makes 9x. You can kind of see how it comes together in like that matrix. And then 2x times negative 4 is negative 8x. And then 3 times negative 4, this is the last step, but don't make it the reason why you get this wrong. You would simply multiply those. You would then go ahead and try to add like terms. They're usually found right here. And then you'd get the same answer. It wouldn't change. It's just another way of completing the problem. All right? If you have any questions. So we've got 3x to the 2nd power, 3x plus 2 to the 2nd power. And let's just remember that an exponent tells you how many times to repeat that. So what this really is 3x plus 2 times 3x plus 2. So it's the same thing being multiplied. Now, I'm going to use the double distribution method first. You can choose what you want to do for your homework, but I'm going to break this first one up into 2 parts. So that's going to give me 3x, and then I'm going to multiply it by this whole second thing. So 3x is going to go right there. So times 3x plus 2. Next up, I'm going to take the 2 and distribute that as well. So plus 2 times 3x plus 2. And this makes sure that I multiply all the terms together. That's really what I'm going for. Now, let's go ahead and multiply using our distributive method. 3 times 3, still 9. 1 plus 1, because we add the exponents when the base is the same. Second power. 3x times 2, how about 6x? Next up, we want to do 2 times 3x. Again, 6x. 2 times 2, 4. Once we get to this point, you always want to check to make sure, do you have like terms? So take a look right here. Yes, we do. 9x squared plus 6 plus 6, 12x plus 4. Okay? So that's the double distribution method. I'll go through the box method real quick and we'll be done. So, box method. Draw a box. Create 4 squares. Then, go ahead and label each column. So use 1 for 3x plus 2. Now this one's a little bit different because it's the same for both binomials. Again, 3x plus 2. Once you do that, multiply to create answers inside the boxes. 3 times 3, and maybe sometimes put a little dot here to remember that this is multiplying. 9, x times x, x squared. 3x plus 2 is 6x. 3x times 2 is 6x. Last step, create a multiplication for that final square. 2 times 2 is 4. Don't forget to combine like terms. It's going to be the same answer, not going to be any different, so just look right there. Okay?